we will have our lecture on geometric optics for today, and we will start that. No, we will have that. No, with our no, some principles that governs probably geometric optics. So when we talk about geometric optics, no, our main focus in geometric optics is to probably determine the image. So the image is the one that you see, when you sit in front of a mirror. The image is the one that you see, yourself, which is behind the mirror most of the time. Now, when you go to a particular mall and you go to a department store, you buy an item there, a shirt, some attire. Now, before you eventually decide to buy it, what you will usually do is to decide to fit it. No? So you go into a fitting room and check, whether the dress that you decided to buy, is actually suited for you. No? So what you see there in front, while you fit that shirt is what you call an image. No? Now, there are different types of images that are made. No? Whenever we sit in front of a mirror, there are images that are considered virtual. There are images that are considered real. No? And again, we have varied types of mirror as well. No? So mirrors, of course, will cause this phenomenon of light that is called reflection to occur. No? So mirrors are kind of reflection that we consider as specular reflection. And the images that are generated by our mirrors now may probably depend whether they are plane mirrors, the flat ones, whether they are convex mirror, or whether they are made of concave mirror. No? So hopefully now we will have and discuss all those different kinds of mirrors. Now let's have uh, geometric optics. So this is the branch of physics, according to this definition, that looks into the creation of images. So again, as I've mentioned, most common images are considered as we consider usually virtual images. And moving on, we have the different rules probably that governs our geometric optics. So number one is that light is a flow of photons, and they have some kind of a wavelength. No? So we understand that photons are the particles of light because light is both a wave and at the same time a particle. No? So these massless particles are called or considered as photons. Or this ray of light that is traveling maybe from the sun towards the earth are believed to travel in a straight line in free space. So but these light rays that are considered to travel in a straight ray are generated by a wave which we already understand as electromagnetic wave. So this electromagnetic wave are also producing this visible light. This visible light is just a tiny portion of that electromagnetic wave. So these light waves or light rays does not interfere, or they do not interfere with each other as they cross. And again, it seems when cars gets into an intersection and they happen to bump to each other, you'll notice that they are affected whenever objects with masses collides with each other, but not for light. Light can intersect or they can meet at a particular juncture, but their direction is not altered. They are not changed. Light rays also obey the laws of reflection and refraction. So for the law of reflection, we understand that there are two things, no, that governs the law of reflection. No? One is that, no, the angle of incidence and the angle of reflection are equal. And likewise, no, there are three lines that are involved in reflection. No? The incident ray, the normal line, and the reflected ray. No? Now, all these three lines are falling, no, or they fall within um, the same plane, no, or they are called coplanar. No? So these are the two principles that bind together, no, our law of reflection. Now, for our law of refraction of light, no, what we usually refer to that one is the Snell's law. No? And Snell's law basically uses the concepts of the index of refraction. We have the angles of incidence also, and the angle of refraction. No? Now, when light enters into a certain medium, no, when it travels from medium number one to medium number two, no, because it will be passing into two different materials, like for example, air to glass, no, or air into water, then light there will tend to change its direction, no, because of either speeding up or slowing down. No? So when materials or when light travels faster, no, from one medium to the next, then there's a thing that is created, no, that we call as refraction of light. No? Now we see that when we have, no, when we dip a particular kind, when we dip, no, a spoon into, no, into a glass of water. No? Okay, now the principal objective probably, no, it's not principal, but it's principal objective of geometric optics is to determine probably, not only the nature of the image, but probably, where the image is found. No? But in consideration, no, of the limited time that we have, maybe now we will not really go into the mathematics of where to find this this image. No? So what they usually use, no, to find the location of the image is to use the mirror equation. No? And this mirror equation uses variables like P, Q, no, and F. P stands for the distance of the actual object. No? So if you are seeing me, no, as an actual person, so I am the object. What I see now in the screen is my image. No? So I am the object. I will be placed, no, in a certain position and certain location. No? And my image is also created in front of me. No? That is if I am sitting, no, in front of a mirror. No? So an object, and there's the image that I see. No? So usually, no, they are being referred to with variables like P and Q, no, in a certain equation. No? And so that's the main goal, no, of geometric optics, the location of these images. No? Now, this may be accomplished in two ways. No? Maybe one, no, is to sketch the path, no, of the reflected light. No? So when you determine, no, where the reflected light will go, then most definitely, no, the intersection of this reflected ray um, will determine, no, the position and how will we describe the image. No? So images will always have a characteristic. No? They are either virtual, they are inverted, no? Maybe they are upright, they are magnified. No? Some images appear bigger, and some images appear, no, smaller in some occasions. No? So they are either reduced, magnified, no? They are inverted. No? So maybe, no, if you look at the mirror, you cannot really, no, understand who is in front of you, because actually, no, what happens is that you are being, no, moved upside down. No? So you are being inverted. No? So maybe, no, that's one reason that you could not recognize what is in front of you. No? There are also images that are being projected, no, outside of the mirror, and there are images that are, no, being placed behind the mirror. No? Now, what usually happens in a plane mirror is that we create virtual images. The image that you see is right standing behind the mirror. So that's what we call a virtual image. Now, a virtual image, no, or virtual no, images created by plane mirrors, we also have an advantage because it will create no, a bigger, somewhat no bigger perspective or perception of a room. No? So if the room that you have is a very small room, you can make it larger now by putting a plane mirror. No? So if you have a room no, with a very big or a very wide mirror, you will see that that room is kind of large. No? Okay, so again, there it creates some kind of an illusion no, that there is a bigger area no, in a particular room. No? So reflection is most definitely no, used in plane or in spherical mirrors. So when we refer to spherical mirrors, there are two types of spherical mirrors, or actually no cylindrical mirrors also. So if you have a sphere, no, a ball, and you make that into some kind of a glass, and you coat it, not to make it into a mirror, you can cut it, no, and then you will have a something like a parabolic dish. So if you happen to subscribe, no, if you're a subscriber to one no cable network, no, maybe they will give you a parabolic dish. No? So that is a cut part of a sphere, and they use that not to beam or to reflect no the signal no, that is maybe coming from a satellite towards your no towards a certain location in that parabolic dish, and then therefore no, you will have a maximum no clear signal inside your TV. No? So, but what you have there is actually no, a spherical figure. No? Okay, so that's it. No? So we have spherical mirror, plane mirror, and for refraction, what we have are our lenses. No? So maybe the applications of lenses, we have some telescopes, microscopes, no? Our eyeglasses no? Are examples of lenses. No? So it really helps us a lot. No? So for example, the eyeglass that I'm wearing right now no? Makes things no much more clearer. No? So here is an image of reflection. So reflection is of course no involves three lines. No? So if you look at this figure on the right here, no? So you have an incident ray or an incident line. No? And once it encounters a mirror or a surface, it will eventually reflect. No? Now the typical illustration for reflection is a mirror, but actually no, any images can actually reflect light. Now the reason why we are seeing, no, for example, no, I am holding here a certain container. The reason why I'm seeing this container is that light is reflecting, no, is being reflected from this image. No? So there is a light bulb behind me, and as its light no strikes this object now no reflects the light coming from the bulb no? Or from the fluorescent lamp. And therefore I am seeing that because of the reflected light that is being no, bounced no, by this container. No? So again, no, everything or maybe no, almost everything no, eventually no, has some form of light no, coming from it. No? Either it is the one that is producing it or it is simply reflecting the light. No? Now that reflected light or ray no, will be measured no, with a certain angle. No? So the measurement of the angle is always measured from this vertical line we call as the normal line. No? Now these three lines, no, according to the law of reflection, are falling no, into the same plane. No? We call them as coplanar. No? Now, so that's one principle of reflection, law of reflection. And then the other principle is that this angle of incidence and this angle of reflection are equal. No? So those two principles must always go hand in hand no, in order for reflection to occur. No? Okay, so again, no, part of the principle why we see things no, or images is the behavior or the intersection of this reflected light. No? So it must have no, several reflected light in order for you to create no, some sort or some kind of an image. Okay, so we have here a reflective surface, no, a mirror that we literally no clearly see this jar. No? The jar is being shown no behind the mirror. No? So again, if you notice it, no, the jar now is probably standing behind the mirror. No? Now, we call this kind of image, which is very clear, similar to the one that is in front of it, no, the actual object. We call that a specular reflection. No? So specular reflection is no, creating a very clear image. No? When this one is kind of blurred, no, because of the kind of surface that you have, no, and probably the surface there is very rough, then what you will have is a reflection called diffuse reflection. No? So diffuse reflection, medyo hindi klaro ya ang aton object. No? So the object is kind of blurred. No? Okay, so here is our light. No? So we have a light coming from the candle. No? So if you stand in front of a mirror, you see your image now behind the mirror. No? The location of the image can be diagrammed, knowing that the surface of the mirror reflects light with an angle of reflection equal to the angle of incidence. No? So here is our angle of this is the incident light probably. No? Then it goes to your eye. No? So what you are seeing no, is actually this lighted candle. No? Okay, so because it has light, and that light now bounces off a plane mirror and goes to your eye. No? Now, the angle there must be the same. No? So where is that angle of incidence and reflection? That's on the left side of the mirror. No? So if you draw a vertical, horizontal line here, we call as the normal line. No? So there's a normal line that will go from the middle to the left. No? And the angle of the incidence will be that angle no, with respect to this normal line. No? So if you want, no, you can actually draw a normal line somewhere here. No? So you could have a normal line there. No? The normal line no, will create no, an angle that is called the angle of incidence. No? Now this angle of incidence is actually no, the same as this angle of reflection. No? So because this is the one now that is going to your eye. No? Now this angle of reflection, when you extend it, no, so you project it, no, kaya iniya makadto ni sa matama mo kay surface ni, but however you can actually extend that same line of reflection behind, no, and you'll notice, no, if you draw it straight, its distance, no, from the mirror will be the same distance, no, from the mirror to the candle, no. So usually this is what we call the object distance, and on the other side this is the image distance. No? So usually they call it Q. This one is the one that they call P. No? So for a plane mirror, P and Q are usually equal. No? They are simply the same. No? So again, talking about no, images created no, in front of our mirror. No? So for plane mirrors, images are formed no, behind the mirror, and it is right side up, so meaning it's erect. No? So kung nagatindog man nato sa piyak, wala siya nagasuli yan, no? Ulo yato sa dalom. No? So it's right side up or upright, no? Having the same size, no? So it's not enlarged, it's not reduced. So kung ano ka kadako, amo na to kadako ang plane mirror nga image sa piyak. No? So far behind, no, the surface, no, as the object, no, is in front of it. No? So we call that image nga sa likod, far behind sa likod sa aton mirror as virtual image. No? Ang sa likod. No? So sa likod siya natin makita sa mirror. So the shiny part is on the left side, no? And therefore hindi mo na ito makita na sa kay way na ito galapos yung mata. No? But your object no, will be found at the back. No? Okay, for spherical mirrors, these are again a portion of our either a sphere or maybe a cylindrical shape. No? So kung mayara ka na daw lata, pag doon mo na bala, no? So you'll have something like a curved portion. So you could also consider that as a concave, no? If the shiny part is on this side, no? So kung malantaw ka sa mirror, kaga mo na di ang curved part ang ginalantaw mo, then that's a concave mirror. Pero kung ang iya likod gani, no? Select for example a spoon, ang likod sang spoon, amo na tong ginalantaw mo kag makita mo tsura mo, then that's what we call as a convex mirror, no? So a convex one is protruding, no? The shiny part is the protruding portion, and that's the distinction between concave or convex, no? So images are created there, no? Now, although there are also lenses that we can consider, but most commonly, no, ang aton lang tutukan are mirrors lang, no? To make things, no, a little bit more simplified because of the lack of time, no? So ray diagrams are crucial, no? So you will have there, no? Please remember these terms. Center of curvature, no? We have the geometric center, no, of the mirror is called as the pole. We have line joining the pole of the mirror and the center of curvature, which is called as the principal axis. No? Now we will be probably seeing, no, these things. No? So we have P, we have C. No? I-describe ko na karon kung ano na ang center of curvature. No? So, amo niyang aton nga principal axis. This line that goes to our mirror, no? So, again, no? Ang iniya, we call this as convex, no? Kaya ang shiny part, no, ara, di naga, diri sa iya, left side ang shiny part, no? So, kung maglantaw ka sa self mo, diri kaya dapat matindog sa balato so that you can see yourself, no? What I mentioned about convex mirror earlier is that the images here are usually small, no? Now, if you are standing in front, no, and the curved part, no, is covering you, then this is now called as a concave mirror, no? So the difference between convex and concave mirror, no? Now, the line that is horizontal here, no, we call this as the principal axis, no? So the word is principal axis, no? Okay, so the principal axis contains this pole, no? Ang mga nangin mention niya ang pole, P, no? Others would call this as the vertex, no? The point or vertex, no? But in this diagram, we call it as the pole or letter P. Now, this is the center of curvature, ining may letter C, no? Now, why is it called center of curvature, no, and not center of a circle, no? Now, if you measure this line, no, from the center to the pole P, no, and you consider that as a radius and create, no, a circle, you can actually now make one complete circle. But this one, since it is cut, we simply call it as a center of this is simply called as the radius of curvature na lang, no? But this one is still considered as the center of curvature, no? So but when you make, no, one complete circle, then you can actually create a circle there, no, if you will use this as the center. That's why it's also called center of curvature, no? Now, between the pole and the center of curvature is your focus. How do we measure the focus, no? Or where is the focus found, no? The focus is simply half, no, the value of the point P, no, or pole, and the center of curvature, no? So for example, the radius is 10 centimeter, no? So where is the focus located, no? So maybe from the center, no, you can measure 5 cm if this is a total of 10. So 5 ni ang distance ng F and C together to find, no, or locate your focus, no? And that length, no, from the P to F is known as the focal length. So may mga words kita, focal length, no? Then you have your radius here, no? Radius of curvature, no? So so when there's a parallel beam of light, no, diin makadto ang ining parallel beam of light, no? So if you beam light, no, from infinity, no, so area, no, so if there's light that is coming, no, towards this mirror, ang ina nga light will always be, no, bouncing, no, it will be bouncing, but its line will be traced along the focal point, no? Ano ang isa ka i-consider nato, no? So if light is parallel to the axis, no, to the principal axis, then it will always have, no, to be directed towards the focus, no. So for example, no, ang aton nga person or object, no, since naga-produce na siya sang light, no, may reflected light na sa iya, so maybe from his head may ara nga light nga maghalin, no, kag mabunggo sa mirror. Ini nga light happens to be parallel to the principal axis, no. Di lang principal axis nga ginahambal ko, no. Ang atong principal axis is this one that is below, no. Ano yung principal axis, oh? Diri ni ang tatlo ka points nagaagi sa principal axis, no. Now, once this light that comes from your head, no, strikes the mirror and it is parallel to the plane, our principle that mentions, no, that, no, di na siya makadto iya reflection karon. Ang iya reflection diri na maagi sa focus, no, diri na siya malabay sa focus. So sa F na siya maagi. Okay? Now, ano pa gid ang iban nga reflected light nga pwede matabo, no? Pwede man nga may ara kita di light, no? It's possible that there is some kind of light that comes from the head, no? Pero ang ina nga light will roughly, no, pass the center, no? So inibi na tadlo, ang inibi nga line tadlong ni di sa center, no? Kasi tadlong na sila, ha? So if that is passing through the center or the line nga nagaagi ang center, then ang behavior sang light nga nagaagi sa center ya, no, nga line, ang iya reflection, no, after reaching the mirror, it will be reflected, no, diri siya makadto sa same line. Mabalik na siya di kag diri man na siya maagi balik sa center. Okay, so it will pass the center. Now if you stretch this reflected light, no, all the way sa dalong, and kaina may gin-mention kita nga isa pa ka reflected ray, no. Nang una nga reflected ray, kaina, no, ining parallel line, kung labaon tama ni sa, no, say we will extend it, you'll notice nga ang aton duha ka beam of reflected light, no, nag-intersect na, no? We notice nga ma-intersect na sila, no? So ang ila intersection diri sa dalong will now result, no, to an image, no. So diin ang image sang sining tawo or object, no, nga gamay-gamay siya lang tawon, no. Ang aton nga object ko, no, what happens to the object is that, no, we'll have, no, something like an image that is, no, ang aton image will be formed, no, somewhere here. Ang aton image, guys, no, diri sa karon na form, ang intersection point, no, kagang ulo sang sining arrow, no, will meet, no, and amo na nakadako karon ng image mo, no. So that one will happen. So dahil lang hindi ko masaylo ining figure, no. So dito ang aton intersection sa area digali ayon, no. So let me redraw this. So our image, guys, no, will be kind of inverted, no. Suli na siya karon. Dire na sila matabo. So the image is inverted but it is enlarged, no. So what are ways of describing the image? So one is it is enlarged, no, or magnified. Next, is that it is inverted, and since it is in front, no, of the mirror, so it is also, no, considered as a real, no? Real image, no? Real image kung ara siya sa tubang sang mirror, no? So suli, no? Now kung dito na siya sa likod sang mirror naton makita, no? Then we call it as a virtual image, no? So again, now this is what happens when you put the object between the center and the focus, no? Sang aton nga concave mirror, no? Okay, so I think we have 7:50 na subong, no? We will just continue this next meeting.